Welcome to KK Chemistry. I am Dr. Hasnullah. Okay, here we are going to discuss excited state term symbol for p4 system. You know that when the subshell is S, mean the azimuthal quantum number will be 0, or when the azimuthal quantum number is 1, is subshell notation will be p, okay, etc. Here, if the L, capital L is 0, the spectroscopic term will be S, and so on. Here the particular system is that of oxygen, p4 system. Okay, the electronic configuration of oxygen is 1:2:2 p4. We will be talking about this p4 system. These 4 electrons can be arranged in 3 sets of degenerate orbital for px, py, and pz. As we know that for p subshell we use notation of L is equal to 1. Okay, so if L is equal to 1, the subshell will be P. Okay, the rotation of this subshell is +1, 0, and -1 under a magnetic field. So these 4 electrons can be arranged in different ways in these 3 degenerate orbitals. Okay, now question might be in your mind, how many ways will be there to arrange these electrons? You can just calculate it from the number of microstate formula. Okay, we have also discussed it in previous lectures. So as we have 4 electrons, okay, just for L, here it is 1. For first electron it is 1, for second electron -1, again for the second electron it is 2, L is 1, for the second electron it is -2, for L it is equal to 1, for the electron it is third electron here over here -3, and here it is 4. Okay, for the fourth one electrons. Now you can just like divide them, multiply them, and the result will be 15. Here this 15 means that we have 15 ways of arranging these electrons, just like we have done with p2 system. So you can say that p2 system is equal to p4, means in p4 we have also 15 possible ways of arranging these electrons. In p2 we also have 15 possible ways of arranging these electrons. So the term symbol for p2 and p4 will be the same. The only difference will be in the J value, because for p2 system it is less than half well, we will select the lower J value for the ground state, and p4 is more than half well, so for the ground state we will consider the term symbol with the higher J value. Okay, here again just remove these. Again here we can say that p2 system is having 2 electrons and p4 system is having 2 holes, mean less than 2 electrons. So it is a 2 electron, it is a 2 hole system. So hole formation, equal to hole formation, this p2 system is equal in terms of 2 electrons to P4 in terms of two holes. If a question is asked to derive term symbols for P4 excited state, you can calculate it easily by saying that as we know that P2 electrons, like 2 electrons of P2 is equal to 2 holes of P4, so we can derive term symbol for P2, and the last you can just use the higher J value of P4 for the ground state term symbol. Okay, you can just perform the excited state for P2 instead of a P4, because we know that P2 system is equal to P4. Just to avoid confusion for calculating or deriving P4 term symbol for this particular one, you can also calculate it for P2, but keep in mind that the ground state will be that one for P4 system having the higher J value. We will just prove it in our lecture, that will be lecture number 17 or 18. Complete pigeonhole diagram for P4 system. You can just arrange these electrons, but keep in mind, just place these pair electron in the most higher ml value. Okay, now you can calculate the ml, as we know that ml is equal to plus 1 0 minus 1, that's 1. Okay, so the capital ml will be ml1 plus ml2 plus ml3. Okay, we just want to calculate it for this column. So here plus 1 means electron in ml plus 1, 2 electron. Okay, and here are 2 electrons. Just put these 2 electrons over here, plus 0, so it is 0. The second electron in ml0, how many electron? 1. And the last one is in minus 1. Okay, here 1 electron is over here. Okay, the resultant ml value will be plus 1. Okay, here, got it. Now remember that in case of spin multiplicity, you can add it like you have added while calculating the capital ml value. Here ms is ms1 plus ms2 plus ms3. Okay, here it is 1. How? ms is 1, here ms is 1. How it is 1? Well, you know that it is plus 1, plus half and minus half will be 0, plus half and plus half will be 1. That's why we have written over here ms is equal to 1. Just put this 1 in this multiplicity formula, you will get a triplet. Okay, same way you can just add for the singlet. Here all the electrons are paired. How? This one is paired, plus half minus half 0, plus half and minus half 0. So the spin multiplicity will be singlet. Remember that spin multiplicity can never be 0 or negative. This is why we ignore this one. Okay, it will be easy to calculate term symbol for P4 system by using the partial pigeonhole diagram. Okay, again here we have L equal to 1, the ml value will be plus 1, That's 0, minus 1. Arrange the electron in the pigeon according to the pigeonhole rule. So we have three sets. Set 1 where the ml value is 1 mean maximum. So if ml is 1, definitely we will have plus 1, 0 and minus 1. Okay, if ml is equal to 1, term will be p, as plus 1, 0, minus 1 lies in the triplet state. So the term will be triplet p, as s is equal to 1 and l is equal to 1. You can also calculate the j value if you want, just to know the ground state. Okay, it will be 2, 1, 0. Of course, this one will be the ground state for p4 system. For p2, sorry, for p2 system, and this will be the ground state for p4 system. Okay, the only difference between p2 and p4 system ground state is the j value. Now set 2, where ml value is 2, mean higher ml value, definitely the ml, the small ml value plus 2, plus 1, 0, minus 1, minus 2. Okay, the small l value plus 2, plus 1, 0, minus 1, minus 2, term will be d, because l is equal to 2, as this plus 2 plus 1, 0, minus 1, minus 2 lies in the singlet state, where s is equal to 0 here. So term will be singlet d. If you want to go for the j value, just put l is equal to 2 and s is equal to 0. You will get singlet d2. For the term third symbol, l is equal to 0. Okay, this one. Term will be s. S spin multiplicity is 1, so it is singlet s. As this 0 lies, you can say singlet state. That's why we can write 1 over here. As s is equal to 0 and l is equal to 0, just if you want to put the j value, put these values over here. You will get 0. Mean term symbol is singlet s0. Okay, the total term symbols are right here, and the according to Hund's rule, if we have half filled or more than half filled at all, then term symbol will be that one having highest spin multiplicity, L value and a J value. So this is the ground state term symbol. The total degeneracy can be calculated as we have previously done. It is equal to the orbital degeneracy and spin multiplicity. So just put the values of L and S. You can get 9 possible ways. It also shows that this one can be split in different ways. Okay, 5 is for D and 1 is for S. So we have total 15 to degeneracy, meaning the total degeneracy is 15, showing that we have 15 possible ways of arranging these electrons for this particular term symbol. Thank you. Please subscribe, share and like. Thank you.